Good morning, everyone, and welcome to KETIV's Autodesk Virtual Academy. I'm Nigel Mbayak, application engineer and host for today. I'm joined today by Javier Chavez, one of our senior application engineers on the team. How's it going, Jav?
Good. Hey, everybody.
Hey, yeah, you might recognize Jav. He's been on here a couple of times. Probably Jav's, I don't know, half a dozen, maybe a dozen now almost.
At least. So I've been here a good, 13 plus years. So I've been on a few webcasts.
Just on a few. Yeah. Certainly. All right. So today we're going to be going over Nastran In-CAD. And for those of you who don't know what that is already, just give you a little lowdown on it. So Nastran In-CAD's an finite element analysis software that Autodesk had acquired a couple of years ago and then embedded it into CAD softwares like Inventor and SolidWorks. I'm sure Jav will go over a little bit of the particulars about that shortly. But did I miss anything? Pretty much that's the gist of it, right?
Yeah. And I think what you can expect too from this session is that it's not necessarily like a step-by-step, tutorial on how to use it. So keep that in mind. There's only so much we can cover in this session. We basically want to show you how you can access it, some simple steps, some basic workflows to use it. Obviously, if you need more than that, there's some resources, and we'll talk about those.
Yeah, certainly. Yeah. We do have a training class coming in a couple of weeks. It's about a month from now too. So if Nastran In-CAD is something you want to learn or your colleagues want to learn, definitely let us know. We can kind of help you get in the right direction for that. So if we want to continue to the next slide here, Jav.
Sure. So let's talk about our objectives for today, right? We want to make sure that you guys know why we're talking about this now, and maybe give you some examples of simulations that you can do, far beyond what you can do with just regular Inventor. So we want to give you some of those and show you some ways to get started.
Yep.
So with that said, let's talk a little bit about why, right? And so the first thing I think we can talk about is the low cost, and using some of these FEA tools. One of the challenges is cost, and it's a separate tool, and you got hardware issues, and so with that said, I mean, this tool is now included in the collections. So if you have a product design and manufacturing collection available to you, then you already have this tool. You just have to download it and install it, and certainly if you need help, we can help you download it, get it installed and up and running.
Definitely, it's a lot different than before, where something like a alternative simulation software, things like ANSYS, traditionally are in the entry point of the thousands of dollars.
Yep.
Even Nastran was thousands of dollars before they included in the collection. So definitely now you don't have to worry about that added cost, and it's just like, hey, I have my CAD tools, and it, conveniently included in that package is a simulation tool that I can use.
Yeah,
really awesome.
And so, one of the other benefits is the fact that it's embedded in your CAD tool. So you don't have to leave the design process. I mean, it could even be a thought while you're working on the design. What if I do this? And you can quickly change to that and test it and see if it passes, some of your requirements, and you can go on and decide, whether to keep that change or not. So we'll talk about some more benefits on top of that in just a moment. And obviously you get some advanced capabilities. So some things you just couldn't do before, things that are in the nonlinear range when it comes to materials or forces, and even, goes beyond that. So we'll take a look at that in just a moment as well. But one of the big things is the solver itself is a trusted name in that community. So it has its roots in NASA. So again, very well trusted in the simulation community, and I think if you ask people, about Nastran, they'll recognize it right away. So with that said, let's go ahead and dive a little bit deeper as to, some of the reasons you might benefit from CAD embedded analysis, right? So if you look at this chart, we have time on the bottom line there, and as time goes by and we go from conceptualization to design, to eventually testing, and eventually actually manufacturing this, the cost goes up in terms of making changes and making corrections, and our ability to influence the design, right? Once it's out the door, we're just fixing things. We're creating band-aids for things. So if we do this early in the design process, obviously we can reap the benefits of capturing, so these changes early in the process, right? So best time to simulate is in that design process. And the fact that, you know, it's embedded in the tool just should enable that, right? So that's one of those things we want to make sure we get through to you guys. So another thing we want to talk about are the capabilities. And when you're doing a simulation or you're working on a product, you have to ask yourself a couple questions, right? Do you use various materials? Do you require, you know, various connectors or bolts, welds? Does your product shake or get dropped? Those are some of the things you might want to ask yourself. And if we keep going down the list, there's quite a few more. You know, how does temperature affect your design? Do you have moving components or parts within your design? So, you know, do we have parts that can buckle? So we're going to attempt to answer some of those today, and then, you know, highlight just a few other things, you know, benefits or capabilities in the tool that should help you answer some of these questions. So if you look through this list, the most basic capability there is linear static analysis, right? So we're talking about a load that's where maybe the application of the load is not important. It's not applied abruptly. It's simply placed on the mechanism or design, and we solve for that. Does it deform? Does it you know, go beyond the yield, right? So in addition to that, right, we might want to see what thermal stress does in that environment. So, you know, that first box is just, you know, I know it's very simplified, but there's a little bit more to it than what Inventor simulation can do. So put Nastran into that, and we could also take into account pre-stress, inertial relief, mass properties, things of that nature. So if you look down the line, we have, you know, things like buckling and normal modes. Normal modes, another thing that Inventor can do with just the professional package. But then what you do with the normal modes after that is a bit different, right? We can take it to other types of analysis. So take a look at that list. You know, I'm not going to read through every single one of those, but obviously, you know, materials is a big deal. Besides non-linear materials, we can also support composites, right? So changing the list up again a little bit, here's some advanced capabilities. Take a look at some of these. This is where we start to look at nonlinear static and nonlinear steady state heat transfers. We start to look at transient response, and that's where those normal modes come in and start to work with some of these analyses as well. Okay, so if you guys have any vibration in your design, or you have to account for it, or you have to compensate for it, right? This is probably where you want to be. So with that said, let's go ahead and take a look at maybe some examples. We'll start with buckling here in just a moment, and just show you some ways that we could also maybe account for bolted connections and heat transfer. It's fairly straightforward. Some of these take a while to solve, so we're not necessarily going to solve them here right in front of you. Nobody wants to wait 4 to 10 to 20 minutes for these to solve, but we're going to show you, you know, what the basic process looks like, what the tool looks like while it's embedded in the CAD tool. So I'm going to go ahead and switch over to Inventor here for just a moment, and I'll start with an assembly here that's pictured. Basically, we have a boom here, obviously made to carry and lift heavy loads. And if we isolate just the boom, we want to see, you know, if we have a certain load at the end of that, what's going to happen? What kind of stresses are we going to incur? There's some kind of thin wall components here. There's some tubes and some plate steel there. And we want to find out, will it buckle, right? So with that said, we can get into this environment. You can see it's right here. We just have to switch gears a little bit. There's the stress analysis that comes with Inventor Pro. We're not looking at that anymore. We're looking at Autodesk Nastran. So while we're in here, there's information. If you've done any stress analysis in Inventor Pro and some of the loads or constraints are similar, then we can go up here and import some of those loads or constraints from that analysis. So we don't have to start over and start from scratch. Okay, so one of the first things we'll do is just decide, okay, what type of analysis are we going to do? And we can right-click here and edit our analysis. We can take a look at our materials and start to work with that. I think one of the first things I'll do is just start doing that, edit our materials and start to work with that. So with that said, let's go ahead and maybe add a new material here, right? And I'll start to look here. We can certainly work with the materials that were already in there inside your model, but if we can change that, we can do that here as well. So I'm going to go ahead and select material, same material database that we're working with inside of Inventor. And so I'm going to get to my steels here. And get to a steel mild. Okay. And from here, right, we can go ahead and apply this to the model itself. And so we can go ahead and pick components or apply these to the different solids that are here, right? And so with that said, we have steel mild here, and we can also start to work with idealization. So when we talk about idealizations, this is one of those benefits, again, where we can look at this as a simplified version of this model. We can look at it as a solid and mesh it that way. I'm going to I'm going to go up here and decide, okay, how do I want to treat this? I have shell elements, line elements. Again, these are things that are going to make your simulation run faster in many cases and simplify things for you. I'm going to stick to solids here, and I'm going to go and pick all the geometry that's going to use this steel mild, right? So with that said, there we go. Okay, so when it comes to the mesh, you can see it's letting me know, hey, I need to mesh. And so I could basically go from left to right and start changing some of these settings. In this case, I'm going to skip a few steps here and start the mesh. Let's go to mesh, take a look at the mesh settings here. And obviously, if I need to go back and control the mesh a little bit differently, maybe make it a little bit finer or more coarse in different areas, I can come back and do that. This is kind of a global setting. So I'm going to go ahead and type in 20 millimeters here, and I'm going to have this generate the mesh. Okay. And if you notice, this is an assembly, so I'm working with multiple components here. There we go, we're back. I'm working with multiple components, and I almost overlooked this, but I started to look at this, and I've got multiple components. I have to decide, how do these components interact with each other? And so one of the things I can do is I can manually decide, okay, what kind of contact do these have? Is it bonded? Is it sliding? And determine how these interact with each other. This is already preset to be bonded. So if I use automatic contacts, anything within a certain range, proximity range, will get applied as maybe that bonded type of contact. So everything I do starts to show up here. And in fact, I think I'm going to need to remesh here. So I'm going to go ahead and generate the mesh one more time because I just added those bonded contacts. We'll go ahead and allow it to do that. So now we got to get to our loads and constraints. So I could do this from the browser tree. I can do this from up top here, but I'm going to go ahead and start with my constraints. And on this end, I'm going to go ahead and fix this. So this plate is fixed to another component here, and I'm going to basically fix it so it does not move in any direction, and I take away all degrees of freedom. Okay, so I'm going to get just a visual here, and I've got some visual indicators indicating that I've got a constraint there. Okay, on the other end here, I'm going to do something similar, and I'm going to add a load this time. Okay, so I'm just picking this face, and you can see I can tell, well, what kind of load is this? And this is where I can get into the different types of loads, whether it's a body temperature or a temperature here, initial temperature if I'm doing something that's transient. But again, it's as simple as that. We're creating loads. It doesn't matter whether they're force loads or thermal loads. This is where we add them. If I go to advanced options, some customers have asked, and people in training have asked, okay, what if the load varies over time? It's obviously not going to be linear static. I might need to change my simulation here. But here's some options where we can vary through a chart that load, and we can do it for other things as well. Not just loads. We can do it for some of the temperature loads and vary them over time. We could typically make that go up and down and cycle up and down as necessary. So with that said, I'm going to leave it as force. and I'm going to go ahead and put this in the negative Z direction as negative 15 newtons there. Okay. So again, I want to get a visual on that, so I'm going to go ahead and to show me some arrows there, just to confirm that, you know, these are all going in the right direction. Okay, and we're good to go. Okay, so there's another area here where we have a pin that goes through here. So we don't have the pin, and it doesn't necessarily make sense to model it when we can add other types of geometry. So as I scroll down here, one of the things we talked about doing is adding, you know, fasteners. So right click here, and I can go ahead and add new connectors. That's one of the options I don't see at the top. But right here, I can decide, well, what is this? Is this a bolt? Right? And from here, I can go ahead and tell it it's a bolt, whether it's got a bolt and a nut on the other end, or it's tapped into the material itself. I define the bolt diameter, the washer height or size, just so we can see some overlap eventually over that hole. Right? And I can preload this. So that's another thing people ask about in training, because that affects your results, right? You can stiffen things up quite a bit, or stress things, you know, early on in the process just by adding a preload here. So for us, right, this is going to be something different. We're going to go ahead and make it a rod. Okay. And so with the rod here, we're going to go ahead and select, let's see, we're going to go ahead and select a different way to choose this. There we go. So there's endpoint. And let's go and try that again here.
And while you're doing that, Jav, question just came in while you're running through this. In regards to the solving for Nastran, is that all done locally, or can you port that to a server, or are there cloud tools for that?
Good question. It's all done locally. That I know if there's no cloud options like there was in, you know, some of the other tools that we had talked about. So you do have to have, you know, a machine that's maybe a little bit more robust.
Mm-hmm. And when I was talking to some gentlemen from Autodesk, they had mentioned that there were some plans to move in the future to go to cloud in regards to running the solver, but not necessarily use like something like a server farm to be able to do some of these calculations for you.
Okay, so with that said, you know, at this point, you know, we could go ahead and run this. You know, obviously, if we run this, we're just getting the linear static. And at some point, we're going to want to go ahead and change this. So I've got a version of this that's been solved already. We don't want to wait the 4 or 5 minutes for that, and we certainly don't want to wait a little bit longer for the buckling portion of it. But I'll go ahead and show you that here. And so, you know, here's the same model. I'm just going to get to that Nastran environment.
You're already in. The tab's further down, Javier.
Yeah, there we go.
Yeah.
Okay, so let's go to the first analysis, right? We did a linear static analysis. Let's go and take a quick look at that. Okay, so, you know, same loads, same constraints. However, this has already been run. So we're just going to want to take a look at the results. So down towards the bottom here, we'll see results that are unique maybe to the model. Let's go ahead and change here. There we go. And let's go load our results from that.
All right, let's see here. We got a couple more questions. Is Nastran In-CAD multi-threading? That's probably also an Inventor multi-threading question, Jav.
Yeah, so both Inventor and Nastran multi-thread, then that's one of the few things that does multi-thread. So just something for you to note there. So with the results, if we guys are taking a look here, we can decide, what we want to look at here and display it immediately. So right now I'm taking a look at stress, and it's going to take a second to populate here. But I'm starting to look at the stress. I may or may not want to see the deform option, so I can go ahead and uncheck some of these options here. And so right now the contour is just looking at stress, and we're looking at von Mises stress specifically. And so we can kind of start to take a look here and see where some of those higher numbers occur. We've got probes where we can basically select different areas and see what those von Mises stress are.
Yep. And those probes are going to select nodes, right? So anywhere between two elements where those intersect. You can't just do it in like the middle of an element. So.
That's correct. Yeah. So the other thing we may want to take a look at, right? If I take a look at the numbers, I think the highest number here is like 300 megapascals. So we're okay as far as that goes, approaching our yield. We could look at safety factor and see how close we are to that. But I'm going to go ahead and take a look at something else here. We can go ahead and kind of get a more granular look at what we're experiencing here. So I'm going to take a look at the compressive stresses, right? And so colors again will change just a little bit because we're just looking at the compressive stresses here. And I'm going to reverse the colors. So I've got quite a bit of control. And so there's areas here where we have more compressive stresses that are occurring. Right? We take a look down below, and we've got some more compressive stresses that are occurring. Over here, same thing. So, that might be one of those things you might want to take a look at if you're concerned more about a certain type of stress. We can go ahead and filter those out. Right? So I'll go ahead and click OK. And again, we've got various things we can take a look at. I mentioned the safety factor. Those are pretty much ready to go. And if we take a look at the model itself, one of the things that comes up a lot is, are these surface or is this stress I see, is it limited to the surface, or does it actually, go all the way through the part and penetrate that? Well, it's a thin wall part, so it's going to be, I think it's fair enough to say that it probably goes, almost all the way through. But with thicker parts, that's usually an issue. So let's take a look at maybe the other scenario, right? And I'm going to go ahead and activate the linear buckling. So when I go ahead and activate that, again, it was just a setting change. We ran it again. However, we did change something. We changed the load. We had like 15 newtons or 15 newtons, and we changed the load to a single newton. In fact, I'm hovering over here, and you can kind of see there that I've got a single newton. And so when we change to this, to linear buckling, it's going to give us an eigen number, okay? And what we're looking at with that number, it's a factor. We want to find out, okay, when's it going to start to buckle? And we can ask for it to give us, a few modes, different modes, kind of like natural frequency modes, where it's going to buckle. So again, we're going to go ahead and load those results as well. All right, and let's start taking a look. So over here, when I start to look at this, I've got two subcases. This is what it was the original linear static stress, but then when I get these eigen numbers, you can see they show up here, and I've asked for 10 modes to be evaluated. It gives me a factor of that 1 newton. So if you multiply this number by that 1 newton at 30,000 newtons, this is what we're going to see here in just a moment.
Yep, and while we're waiting for this guy to load, it looks like it's pretty quick, but we'll go ahead and answer this question as well. Greg's asking, can you print out a copy of these reports, like via your printer, just so you can get hard copies of everything?
Yeah, excellent question. So yeah, that's very common too, right? Is for us to be able to give somebody who's maybe not in the CAD arena a report of some of these things. So with that said, yes, the answer is yes, and I can show you where that shows up here in just a moment. But if we want to take a quick look at the results here, right? This is exaggerated. We can take a look at maybe the deformation options and have it show us actual. But this is one of the modes you're going to see here. And when it buckles in this mode, right, at this load here, right, this is a factor of that 1 Newton, right? We're going to see some buckling here, and you can actually see the values if I go back here and maybe show yeah, total displacement, right? So it's not much. It's 1 millimeter in terms of a distance, but that is actually quite big when you're thinking of a thin wall component. If it's thin enough, that could be fairly big, right? And so here's another mode that shows up. I'm going to jump over to mode 3 here, and at a number slightly larger, right, we're going to see it deform maybe in a different location. Okay, so this is pretty high, 30,000 newtons. You know, it certainly exceeds our load that we're going to put on there. Where I was thinking, you know, 1,500 to maybe 50 to 20 newtons maybe with this, and this is, you know, starting to buckle here at, I think, 30,000. That's what this shows here. So somebody asked about the report. All right, so let's go ahead and get out of that. And yes, there's certainly ways to create that report as well. Yep. And I'm not finding it at the moment, but if we were to do this, basically you'd get a sort of an HTML type report that you can print out. And I think it also comes in like an RTF. So with that said, we're going to take a quick look here back at our presentation here. We saw some buckling there. We saw some ways where we can add bolted connections. When it comes to heat transfer, it's almost identical, except it's a different load, right? And different constraints. So you saw some of those options there available. Again, not something we want to necessarily run here. But let's talk about maybe a quick summary of what we talked about here just a moment ago. You know, why would you want to do this? The low cost part of it is a big factor, I think, for a lot of people. Easy to use, a little bit easier to access now for quite a few of you guys that have the product design and manufacturing collection. So it's embedded in the CAD, so you don't have to leave your tool. It's the same tool you've been using. It's just a different tab with some additional options, right? Okay, and the advanced capabilities over what you've been doing, maybe in just inventor simulation, should be able to give you a lot more foresight into, you know, how your product's going to perform. I think I've mentioned it before, where this is as close to a crystal ball as you can get, and so the fact that it's, you know, powered by Nastran as a solver, right, should give you some confidence in the results you get as well. Okay. And so we took a look at the examples and kind of showed you what the workflow looks like. Some of those, the buckling maybe took about 4.5 minutes to run or so. I think the linear static maybe took 3 minutes, so it's fairly robust. There's, you know, a workflow to it. You don't want to simulate everything, but that's one of those things you can learn in training, is what to take out, what to keep. So as far as getting started, right, let's talk about, you know, what the next steps are for you guys. There's tutorials within the tool. They're good tutorials. They're fairly detailed, and so you can access those immediately through the tool. Another really good resource is the simulation community. So if you go to simhub.autodesk.com, you can access, there's another subpage there for TV, SimTV. But there's a lot of resources there, not just on Nastran, but all the simulation offerings. Okay, there's discussion boards to ask questions and connect with, like, some of the Autodesk people that are involved in the simulation tools. So, and then last but not least, you know, we have training coming up September 18th and 19th, and you can sign up for that online, or you can give us a call. But that is coming up fairly soon. and it's a 2-day training event here on site. And obviously, if you're out of out of the range of our office, we do it online as well. So it's available online as well. Right. So I think there's probably some more questions. I'm going to go ahead and open it up, Nigel. To
there's a considerable amount of questions, but before that, let's go ahead and just run through this poll real quick. Just real quick, if you're interested in taking the class and want some more information, definitely let us know here in the poll, and we will shoot you out an email with some more information as to how to get to that class. So I'll give everybody about 30 seconds to go ahead and fill this out. While I'm doing this, I'll go ahead and start answering some questions as well. So real quick, is this video going to be posted after this presentation? So for everybody who's been looking for AVA videos last couple of weeks, definitely been getting a little bit behind in regards to the editing for that. We've had a couple people out of the office, so we're unable to do all of them the day of. But today in particular is going to get done today, this afternoon, and it'll go up on our YouTube channel sometime this afternoon or early tomorrow morning. So definitely look on our YouTube channel. That's youtube.com/KETIV Technologies for that video. I'll go ahead and close the poll right now. And Jav, if you just want to jump over to the Q&A slide. Q&A slide, yeah, perfect. Let me go ahead and give you access to the questions as well, Jav, so you can start looking at some as well while we're going over this. Any restrictions against using English units? Not that I know of.
No, I think you'd probably need to give us maybe a little bit more information of what you might be referring to. But you can certainly mix units. You can create your own unit set. And have, millimeters, something metric for a length unit, and have a different unit for like a force.
Or your output.
Yeah, same.
Yeah, it's pretty easy. You can just change everything up. It's pretty configurable in that sense. Nastran's really aware in that case. Same thing in Inventor, right? If you have your Inventor set up to inches and feet, when you're typing in your dimensioning, if you just type in the number and then for millimeters, it'll convert that. So if you're set to pound force by default, but newtons, you can just put in 10 capital N, and it'll recognize it as newtons and convert it for you. Exactly. Yeah. So it's pretty aware of what you're trying to do in those cases for a mixed unit environment, especially those of us who are working, with some people in the U.S. for vendors, and then maybe overseas for downstream things.
Yep.
Can Inventor be used while the solver is running?
Ooh. You could certainly open up another session of it. I just don't know that I'd recommend it. You probably want to have a machine, if for some of the bigger simulations, you want to probably have a machine dedicated to it. And it's a network license typically, so it could pull the license as needed. Yeah,
so in regards to solving it, obviously the more complex your simulation, the more taxing it's going to be on the performance of your machine, right? So if you're going to do a simulation that's going to take 5 to 10 hours, a couple million elements, you're definitely not going to want to open another session of Inventor.
So I think the sweet spot for this too is some of the smaller things that we ask ourselves, like if I add a gusset here, how much is this going to stiffen it? Am I really going to get that much better performance if I just add a gusset? And maybe you don't take the time to really refine the mesh, but you just get a trend. And so obviously if you're going to do a lot of mesh refinement and get more accurate results that way, yeah, you're probably going to look to maybe having a dedicated machine possibly for that. But the simple changes where we just want to get a direction, you could do it and possibly have another session of Inventor up and running.
Yep, yeah, it's pretty straightforward. In that regard, I know that a lot of people use it to figure out, how is it going to react? Not necessarily like what's the deflection going to be, but where is that deflection going to occur? And where are the areas of note that I need to worry about in my design process? Do I need to add a fillet or a gusset in this location to make sure that this doesn't break? Sometimes instead of simulation, people are just taking their models and they're just making them bigger. Sometimes you don't necessarily need to do that. You can save some time and material and in the manufacturing stage if you don't necessarily need to add those large fillets or some of those gussets in those areas. You can just use Nastran to figure that out yourself. Or maybe you are adding those gussets places to strengthen things, and they're just not big enough at the end. You don't necessarily know if you're not simulating. Definitely not a good idea if you send it out into the field and maybe it breaks on you. You're gonna have to send a technician out there to fix it. Not fun. Let's see here real quick. Is this an add-on or is this additional cost? So we went over this at the beginning, but I just want to clarify it at the end here as well. So Nastran In-CAD used to be a separate software that you would purchase as an add-in to your Inventor. As of about early this month, I think it was the first week of August or so, Autodesk decided to add Nastran In-CAD into the product design and manufacturing collection. So they changed it from product design collection to product design and manufacturing collection. They added Nastran In-CAD and Autodesk HSM built into Inventor, as well as SolidWorks. Both of those add-ins are included with the collection for those people who are using a multi-CAD environment. And so those are available now. You cannot buy a standalone Nastran In-CAD anymore. The only way to get it is through the collection, but the collection is cheaper than what Nastran was before. So it's kind of like I'm saving money and getting more stuff. So that's one thing. If you need questions on how to access that, definitely call our Lifeline team or send us an email, and we can figure out whether or not you have access. You know, a lot of people are very confused as to whether they have a suite or a collection or just Inventor, and we can kind of clarify that for you based on your account if you have any questions.
Yeah, and I think Michael had a question. Can you do nonlinear buckling when yield is exceeded? And I think I remember another customer having a similar question. At the moment, I don't think we knew the answer. This is a while back. But if I remember correctly, the answer is yes. You can certainly do nonlinear buckling and find out what happens after it buckles. Get an idea as to what happens after it buckles. Obviously, it's an approximation. It's as to what happens after that. But the answer is yes.
Yeah, and Greg, for that question, can you clarify that a little bit? That's one thing. Just before I answer that one, and then another another question from Michael. Can you add custom material properties for nonlinear analysis?
Yes, the answer is absolutely yes. Yep. In fact, there's the basic material library that is inside of Inventor that you can use. But Nastran also has another library that you can load up, and so that's the kind of cool thing is you can create your own libraries of these materials, so you don't have to create them over and over again and save them on a server or somewhere where you can everybody can access them and not have to recreate them.
Certainly, yeah. So if you need to know how to load custom materials, it is grabbing from the Inventor material library too. So we do have an AVA on how to use that library and kind of manipulate it, add your own things. So if you're interested in that, let us know or go ahead and look that up on our YouTube channel. Just materials library Inventor. You'll be able to find that particular video. All of those materials do carry over to Nastran. You can honestly make whatever you want really in terms of material if you know what your material properties are for that particular material.
Yep.
Greg, let me go ahead and reach out to you offline about that. I'll go ahead and shoot you an email after this webcast and we can kind of figure out exactly what you need, and we'll go through that as well. Let's see here. All right, I'll give everybody about 30 more seconds to go ahead and post any more questions that you do have. And while I do that, I'll go ahead and make a couple of announcements. So next week, we do have another AVA. That's pretty normal, right? We do have these things every week. And so next week's AVA is going to be on Autodesk factory assets. So factory assets and how to use those with Vault. So it's really cool. I just saw Hobbs' eyes light up. And he's like, am I doing that? No, it's actually going to be Jorge Fernandez doing that for us. And the way that you set up factory assets in the factory assets library, while you're using Vault, there is a bit of setup in regards to doing that. It's not as easy as just loading the files into your Vault, checking them out, and using them that way. And Jorge is going to kind of go over that setup, how that works, and he'll give everybody a little bit of a lowdown on how factory works, why you're going to want to use it for your layouts and stuff, and some other use cases for it. So some pretty awesome stuff. Also, next Friday we do have a Fusion Fridays, right? So Autodesk Fusion 360, we do webcasts for those once a month. So next Friday, we're going to have a webcast all about shape optimization, which is something that Nastran also does. And so, you can kind of apply loads to a particular shape and figure out what areas you need to keep and what, areas of material you can get rid of kind of help you lighten some of your assemblies and parts. So really cool. Let's see here. Can you simulate hydrostatic forces?
Yes, and so the answer is yes. And so hydrostatic forces, if you guys remember, I was taking a look at maybe the forces, and there was an advanced tab, and there's a place where you can have a variable load. So obviously, as the hydrostatic forces change depending on something, typically, you know, the elevation, that's when I think of it. Think of a water tank. At the top, the pressure on the walls is not as high as it is, you know, as you get towards the bottom. So yes, absolutely. You just get to specify that however you want, as a chart or as a table, and specify what those forces do as, you know, the elevation changes or parameter changes.
Yep. So again, Jav, thanks again for being here today. If anyone has any questions, definitely give us a call or shoot us an email. The email is on the screen. Or, you know, just go ahead and comment on one of the YouTube videos and we'll be able to get back to you about that. Obviously, we couldn't cover everything in Nastran today. There's like 20 different analysis types in there.
Yes.
And we can't go over everything. But if there's something in particular you want to go over in one of these webcasts, or you want us to, you know, spend some time with you and your colleagues to kind of explain how something works, definitely reach out to us and let us know. We're more than happy to spend some time with you and see if Nastran can possibly be a solution for your solution need or simulation needs, I guess. So with that, thank you everyone for being here today. Thanks, Jav, and we'll see you next week. Thanks, and have a great weekend.